Hello and welcome to Ganesh Institute. So in our previous video we have already talked about vector calculus, that is gradient, divergence and curl. We talked about these topics. Now we want to see what are the applications in fluid mechanics. Okay, in fluid mechanics. So are you excited? Let's get started. First of all, just a brief. If I ask you what is gradient, what is divergence and what is curl, then what would you say? So gradient is a vector field. Remember this bit that it is a vector field and it points out the direction. Obviously, if it is a vector field, it will points out the direction, and that too direction of the greatest ascent, the maximum level for a scalar function. Okay, this is gradient. And for any scalar function, how would you find a gradient? We'll talk about it. You need to simply take partial differentiation, okay, of I, j and k components. Now, if you have to talk about divergence, then how would you explain it? Divergence means outflowingness. Okay, if you have a vector field, you have a gradient, that is the highest point, then you can calculate divergence. So gradient is this del vector, and then if you have dot product with the function, you will get divergence. Okay, what is curl? So if you are asked that what is the definition of divergence, then you can say outflowingness. Okay, outflowingness of a vector field. How much divergence it is having, that vector field is having. Okay, now so this was about divergence. If we talk about curl, then curl has gradient and function, but their cross product. And you know direction matters in cross product. You cannot write it f cross del. It has to be del cross f. But here in divergence, you can write it f dot del as well. But just to remember the position and priority, just to remember that, you can keep it del f. Okay, del cross f. Now, technicality about curl. If someone asks you about the definition, then you can say curl measures how much a vector field curls around a point. So you have a vector. This is the point. So if that vector is rotating, so how much it rotates, it curls. Okay, a vector, just bear with me, a vector field curls around a point. Okay, this is the definition of curl. Now you have got some clarity, or you can check out those videos in which I have explained in detail those questions of gradient, divergence and curl. Okay, now let's begin that what all applications can we use these things in as far as fluid mechanics is concerned. Okay, so here is the question. Looks complex one, right? A fluid motion is given by V is equal to y plus z iota, I vector, z plus x j vector, x plus y k vector. Show that the motion is irrotational. Okay, we have to show that this vector v has irrotational motion. Then we have to prove that this is the case of steady incompressible fluid. And then we are also supposed to find out the velocity potential or scalar potential. All right, then let's begin. So first of all, what is given to us? V, no, it's not visible. V, which is y plus z I cap, z plus x j cap, and x plus y k cap. You know that these are unit vectors I, j, k in x, y, z directions respectively, right? Okay. If you have to prove that this is for incompressible fluid first, so you should know what is the theory for steady incompressible flow. So for steady incompressible flow, the continuity equation, have you read about it? The continuity equation states that if there is a fluid having steady incompressible flow, then the vectors, if you do partial differentiation of u, v and w, let's say that flow has these position vectors, so del u by del x, del v by del y, and del w by del z will be 0. Okay, if it comes out to be 0, then you can say it is a steady incompressible flow. So let's check it out. If you compare these UVW with what we have got here in main vector, you will see that on comparison U is the x component, this one, y plus z, right? What is V? V is z plus x, and what is W? It is x plus y. Is it okay? So if you substitute all these values in this first equation of continuity, so I'll get del by del x of y plus z, del by del y of v, v is z plus x, plus del by del z of w, that is x plus y, equals 0. Now if you see, if you expand it, distribute it, so del y by del x will become, because it is partial differentiation, you have to look for the x component. There is no x component in y plus z, so the differentiation, the partial differentiation will be 0. Then again for z and x in respect to y, it will give you 0. Then for x and y with respect to 0, it will give you 0. So this sort of equation, yes, it proves that this may be the case of steady incompressible fluid. Okay, the first part is done. I mean, one of its parts. This one is done. Now we have to show that the motion is irrotational. Okay, irrotational. So how can we do that? Do you know, we just studied about curl, that there is a point and curl measures how much a vector field curls around a point, right? If I'm supposed to show that motion is irrotational, then that means curl has to be 0. There should be no curl in around the point, around the vector field. Yes or no? So let's prove that the curl is 0. Let's check it out. So again, let me write v. V is y plus z I vector, then z plus x j vector, and then x plus y k vector. This was the question. Now we have to show that motion is irrotational. And for irrotational, what's the condition? That curl v has to be 0. So if we are supposed to prove it, then let's check out whether we are getting 0 or not. So curl v, let's find it out. And how do we calculate curl? Gradient cross function. Function is v here, right? So this has to be this way, in a matrix form, like determinant you can find out. To find out gradient, how do you calculate it? You have to write I, j, k vectors here. Okay, and then you write in the second row the differentiation, the partial differentiation. I, that means with respect to x, j means with respect to y, and k means with respect to z. And now, because this is 3D motion, we have I, j, k, so third row has to be there. Third row will be your coefficients, you can say, with I, j and k components. So y plus z, z plus x, let's keep them in bracket, and then x plus y. Do you know how to calculate determinant? If you have firstly you have to separate these three, I, j, k. I, because it is first row second column, so that means first row second column, its sum is odd, so minus j, and this is third row third column, summation is 6, so it is positive. Now you have to write here what if you are considering I, so just forget about first row in which I is there and the first column in which I is there. What is left? Cross multiply with minus sign in between. So del, I need to change the pen, del by del y of, firstly, what it is? X plus y. Let me make it square close bracket. X plus y, right? Minus, here del by del z. Here is what? Del by del z of z plus x. Correct? Then if you have j, so you will forget about the row in which, the column and row in which j is there. So what is left? This and this one. So that means del by del x of x plus y minus del by del z of y plus z. Yes or no? And then with k, what we have? You have to forget about this column and this row. So these two things are left. I'm hoping that you can see it, what I'm doing. Del by del x of z plus x minus del by del y of y plus z. You know, this much you should remember, that how to solve a matrix and how to find out determinant. Still, I'm hoping that it is clear. Once you got it, then differentiate. You know, it has x and y component. If you do the differentiation of x with respect to y, it will give you 0. But with y with respect to y, it will give you 1. Then z with respect to z will give you 1. And x with respect to z will give you 0. Because it is partial differentiation, okay? So this is 1. This is 1. What is left? I, 1 minus 1. It is minus here. So minus j, what is here? If you do, this is what? Z plus y. This is x plus y, right? X plus y and y plus z. Okay, if you do x with respect to x, again 1. And y with respect to x, 0. Y with respect to z, 0. Z with respect to z, 1. So minus 1 plus k, z with respect to x, 0. X with respect to x, 1. Minus y with respect to y, 1. Z with respect to y, 0. So you can simply say that because curl is 0, hence motion is irrotational. So we are done with second part as well. Let's move on to the final part, which is far important than what we have studied so far. Let's begin. So let me rewrite the vector for you. Y plus zi, z plus xj, and x plus yk. The third part is you have to find out the velocity potential. Velocity potential, or you may call it this v. If you don't talk about the direction, then you have to simply find out the function, the scalar potential. Okay? How can you calculate that? This is the major question. So whenever you are asked to find out the potential of a vector field, okay, how do you calculate that? This is v, right? You have to find out del and phi. Okay, this is, you know, this is gradient. And what is phi here? It is the angle. Okay, now angle of rotation, you can say. And this is what we have to find out, the potential. Okay, we have to find out the phi, value of phi. How can we calculate that? So this is first point, that your function will be gradient and that angle. the product of these two. Now firstly, in order to get phi, let's see how can we do or solve d phi. D phi is basically differentiation of potential. Do you know total differentiation? If I have to find out total of phi, can I do it like partial differentiation of phi but multiply it with the x component, the full differentiation, then with respect to y, then full dy, and then with respect to z, and then full z. Remember about the sign. This is partial differentiation, this is full differentiation, right? So because I have to find out the differentiation of a function, phi is also a kind of function, right? So if I have to find out that differentiation, firstly I have expanded it this way. Can I do divergence as well? Like let's say there is some r vector and that can be multiplied by it. R, I am supposing that it is xi, yj and zk, any distance position vector. Okay, so divergence will be the dot product. So this is your function phi and you have to find out this is gradient. Okay, now the function I'm having if you consider this r, so what will be the dr? Because I am having d phi here, so I need to write dr, not only r. So I will write I dx, j dy and k dz. Is it fine? This is complex. Please try to understand that I am trying to find out phi, and in order to get phi, I'll firstly start with d phi, and then I will integrate it. I will integrate d phi and I'll get phi. Okay, but before going ahead, I need to know what is d phi. Now differentiation of any function, can I find this using the divergence of two vectors, right? Divergence of two vectors. So that means gradient, the total differentiation with respect to the position vector. Okay, because this is dr. dr is dx I dyz, sorry, dyj and dzk, right? This is dr. So that means this is dr. Okay, can I write it as this is our gradient? Yes or no? Gradient of what? Phi, and this is our dr. Yes or no? Is it clear? So this is our second equation now. This is dr. Okay, now because dr is I dx, j dy and z dk, right? So I'm writing it as d phi is equals to, see, this is gradient, this is phi. What is from first equation? This is v. This becomes v dr. Yes or no? Now you have v here. If you do the dot product with dr, do the dot product of these two. You know in dot product we only multiply the coefficients of I vectors with I vectors, j vectors with j vectors and k vectors with k vectors. Because if you multiply the dot, if you do the dot product of I, j, k, kn, that will be 0. So what I'm doing, I'm multiplying this with I component. What I'll get? X into, yes or no? X into y plus z. Yes. See, this is y plus z. I am multiplying v with dr. Okay. So v is here, dr is here. I dot I will become 1. What is left? Dx into y plus z. Yes or no? Y plus z into dx. Plus this j dot j will become 1. So dy into z plus x. So z plus x into dy. Plus this is k and dot k. This will become 1. So x plus y into dz. Yes or no? This is what we have got in terms of d phi. Is it fine? Now can you elaborate it? Expand it. It will become, d phi becomes y dx plus z dx, z dy plus x dy plus x dz plus y dz. Yes or no? I have just simply multiplied and distribute. Okay? Alright. Now can you see this y dx, this is having differentiation with respect to x, right? And where else we have dy, this is y dx, and now here we have x dy. If I group them together, can you see if I have, let's say, xy, and I want to differentiate it, what I'll use? Product rule. X as it is differentiation of y plus y as it is differentiation of x. So can I do the converse? Can I write it as xy? Yes or no? Similarly, z dx. You have dx here, so now you need dz. So here, if you group them together, z dx and x dz. Similarly, z dy and y dz. What will you get? This is the product rule of xy. This is for xz, and this is for zy, or we can say yz. Yes or no? Okay. And you will say that differentiation of this product. Correct? This is the differentiation. But I only need phi because this is our velocity potential. So how can I calculate phi? Simply integrate. If you integrate both sides, on integrating you will see that this is d phi will be phi. Here all d's will be gone. You will get xy, xz, yz and an integration constant. So this is our velocity potential. This is a bit complex, but try to revise it, pause it and try to work it out on your own, and I'll assure you that you'll be able to get it. And if you have any difficulty and if you like this video, you can comment and share your thoughts on it. Thank you so much for watching this video. Till our next video, take care of yourself. Bye bye.